All right, we're going to look at sections 9.1 and 9.2, which have to do with simplifying, multiplying, dividing, adding, and subtracting rational expressions. So let's start with some simplifying. So the key thing on this whole test is going to be us remembering that in order to cancel something out, we have to factor. And so you might be inclined to try to mark things out on number one, the way that it's set up, but we can't mark anything out until we've factored. So the top I can't do anything with because there's nothing in common in those two terms, but on the bottom I can do what multiplies to get 9 and adds to get 10, so I can split these up into two parentheses. So 9 and 1 multiply to get 9 and add to get 10. And so once I do that, now if there's something that's alike on top and bottom, I can cancel them out. So the k plus 1 on top and the k plus 1 on bottom, those do cancel. When I cancel everything from the top, I have to put a 1 to show that it's a fraction, because this k plus 9 has to be on the bottom of our fraction. It will not be on top. Now, the other thing that it asks us besides simplifying is it asks us to state our restrictions, or another way of saying that is the excluded values for our variables. So our variable is k, and we want to look at this step after we factored, and we want to say, well, we know that k can't be negative 9, and we know it can't be negative 1. And our logic there is to say what numbers, if I plug them in right here or right here, give me a 0. Well, negative 9 plus 9 gives me 0. Negative 1 plus 1 gives me 0. If you have problems with that, set each part equal to 0 and solve. That's on the bottom. So I'd subtract 9 over, I'd subtract 1 over, and then I would get these for my restrictions. Now again, you might look at this and say, oh, hey, let me get rid of those 15s, but that's not how it works, because everything has to have it in common on top and bottom because of this plus sign. If we were multiplying these together, yes, we could cross out the 15s, but because on top we're adding two things together, we have to be able to take out something that they have in common. So 10 and 15 both have a 5 that I can divide by, and if I do, I'm left with 2b plus 3, and on bottom I still have 15. And the idea here is that now that the 5 is on the outside and I'm now multiplying 5 times 2b plus 3, I can cancel this 5 with the 15 on the bottom and get 2b plus 3 over 3. Now, we need to look back before we canceled, and we need to say on this one, there isn't a letter on bottom, which means there are no restrictions. So in that blank, we would say either NA for not applicable or none, or I would be fine with you leaving it blank even if there really isn't a restriction, like in this case. And that was because there's not a B on the bottom anywhere in our problem. Number 3, let's factor the top. This is something that you need to just try to get the hang of, noticing that I can multiply negative 5 and 5 to get negative 25, and when I add them together, they cancel each other out, which is how I don't have a middle term on top. And then on bottom, I have n minus 5, and so I'm going to cancel out my n minus 5s and get n plus 5. And since everything canceled from the bottom, it'd be like there's a 1 on bottom. I don't have to actually put the 1 from the bottom like I do if the 1 is on top. So n plus 5 is my answer, and I have to look at, before I canceled, what can n not be? So n can't be 5 because of the n minus 5 on the bottom of our fraction. On top, we have a number that we can divide into both of these, which would be 7. You want to make sure that if you come up with something that's going to divide into them, you have to write it on the outside. It doesn't just go away and you don't have a 7 anymore. You write 7 and then you write what's left over if you take out 7. On the bottom, we need what multiplies to get 70 and adds to get 17, which will be 10 and 7. Now, the n plus 10s will cancel, and on top we'll have 7 over n plus 7. Now, when we're simplifying, or when we're looking at this and thinking about what we're doing, we might be like, oh, hey, those 7s would cancel. But that's not how it works, and you have to somehow get it in your head that it doesn't work that way, because I'm adding on bottom. And so if you're trying to say the 7s would cancel out, think about if n was really a number like 1. Well, 7 over 1 plus 7 is 7/8. And you could find the decimal of that if you wanted to, but if I cancel these out, if that's what I think I can do, that gives me 1 over 1, 1 over 2. However you would work that out, it's not 7/8 because I'm not allowed to do that. I'm not allowed to cancel it out. That's different than if this was multiplication on bottom. Then I can cancel them out because this is 7 over 7, which is 1. Okay, so this situation with the plus sign, that's why I can't cancel the 7s. Now, I need to think about before I canceled out what was in not allowed to be because it was on bottom, -10 and -7. Now we're going to either multiply or divide. So multiplying, we multiply straight across the top and straight across the bottom. There's a couple different ways to do this. You can go ahead and multiply and get 80p over 10p squared, and then simplify. So 80 over 10 gives us 8, and p over p squared gives us a p on bottom because there's one more p on bottom than there was on top. That would be our answer. You also, though, if you are comfortable with it, you can cancel things out up at the front, like the 10 and the 5 and the 2 will cancel, and p squared cancel to give us just p on bottom, and so we'd get 8 over p that way as well. It just depends on which way you're more comfortable with. P cannot be 0 because I had 5p squared on the bottom, and if I think about where that equals 0, my only option is to put a 0 in where p is. Now, this is a situation where I want to factor, if possible, because I have some minus signs over here. And so the top, I have a 5r in common, which leaves me with r minus 3, which is convenient because I have an r minus 3 on bottom, so I can cancel out these r minus 3s. I also can cancel some more things out. Let me go ahead and multiply 10r squared over 3r squared, which means the r squareds cancel, and I get 10 over 3. So the place that I want to look at for my restrictions is either in the middle here or at the beginning. Either one would work. R can't be 0 because of the r squared, and r can't be 3 because of the r minus 3. Now when we divide, the biggest thing for us to remember is we have to flip the second fraction. And once we do, it becomes a multiplication problem, so we just follow our multiplication rules. So I'm going to change it to multiplication, and the bottom becomes top, and the top becomes bottom. And so what happens is that Now that I flipped them, the x plus 4's can cancel, the x plus 3's can cancel, and I'm left with x minus 6 over 7. My restrictions, I need to look at the beginning before I divide it, and I need to say what could x not equal there at the beginning. And so it couldn't be negative 3, it couldn't be 6, and it couldn't be negative 3 again. We don't have to write that again, we can just write it once. (16n over 12 divided by 15 over 2n). And this is where you have to remember, since we're dividing, we've got to flip. Otherwise, you would start trying to cancel things out, and that's not going to work to get us the right answer. 16n over 12 times 2n over 15. So again, we can do this two different ways. I can multiply this out on top and get 32n squared. 12 times 15 is 180. Now 32 over 180 definitely simplifies, and it might be tricky to get what it simplifies to be. You can type in 32 over 180 into your calculator and then change it back to a fraction. I know they both divide by 2 and then by 2 again, and that's as far as I can go. So it's 8n squared over 45. And then at the beginning, I had an n on the bottom, that 2n, so that means n can't be 0. Now on this one, I'm going to have to flip the second fraction, but we might as well go ahead and factor and see what's on the bottom of our fractions. If I want to multiply to get 32 and add to get 12, that's 8 and 4. And then if I want to multiply to get negative 8 and add to get 7, that's plus 8 and minus 1. Now I can list out what m can't be at this point if I want to, because it can't be a negative 8, negative 4, positive 1. And now let's flip. So now m plus 8 and m minus 1 will be on top, and m minus 1 will be on bottom. The m plus 8's cancel, the m minus 1's cancel, leaving me with 3m over m plus 4. Now we're going to switch to addition and subtraction, and it may seem weird, but multiplying and dividing and addition and subtraction with fractions are in many ways completely different, because multiplication I just factor and then try to cancel out anything that is similar. But the biggest thing with adding and subtracting is trying to get common denominators. So a common denominator is a denominator that's the same for both, which both of these have the same. So I can actually just go ahead and add the numerators together right away. So I'm going to have 6u plus another u, which gives me 7u, and then negative 5v plus negative 5v, which is negative 10v. Now, once we've added our numerators together and added all of our like terms, and in some cases like distributed and things like that, I need to check to see if I can simplify. The only way I can simplify is if I can factor the top. So since 7u and 10v have nothing in common, I can't factor, which means this is my answer. For my restrictions, u can't be 0, and v also can't be 0, okay, because we have two letters on bottom, and neither one of them, that means neither one of them can be 0, or would make our denominator 0. One thing that might trip you up is, why doesn't our denominator change? Well, think about if you have a third of something and you add another third of something, what do you have? You have 2/3. So the bottom doesn't change into something else when we're adding. It just stays that same denominator the whole way through. Now, a lot of the times what we can do is if we have different denominators, we can just multiply them together to get our common denominator. Sometimes there's a better denominator, but if all else fails and otherwise you'd basically be doing nothing on a problem, you definitely want to try just combining our numerators. So the first fraction has n plus 3 on bottom, which means we need an n plus 1. And so the rule is what we do on the bottom, we have to do the top. And then the n plus 1 needs an n plus 3 on top and bottom. So I kind of wrote that backwards, but we're multiplying by n plus 1 on the first fraction and n plus 3 on the second one, which means we're going to have to distribute on top of each fraction. So 2n times n is 2n squared, 2n times 1 is 2n, 5 times n is 5n, and 5 times 3 is 15. So I have like terms in the middle, and now if I wanted to try to factor the top, since it's a 2n, I'd have to slide and divide. And so honestly, most of the time when we're adding and subtracting fractions, we won't be able to simplify. But to do a quick check, if I slide and divide, I have to think about the 2 times 15 would be 30. And so is there anything that multiplies to get 30 that will add to get a 7? Well, if I was subtracting, yes. But because it's addition, because I'm multiplying to get positive 30, then there's nothing. So this is our answer. On bottom, we know that n can't be negative 3. N can't be negative 3 because of this, and it can't be negative 1 because of the other. (12) 5x over 2x times x plus 3 plus 5x over 2. Now this is a case where there's actually a best denominator to use that gets us to the right answer first. And so you might see they both have 2's, which means we only need a single 2 and then x times x plus 3. If you put 4 here because you're like, oh, I need to do 2 times 2, it'll work. We'll just maybe have more simplification than we really needed to have to do. So the first fraction has all of this, so we don't need to multiply the first one by anything. It would just be 5x. The second one needs a lot, though. It needs x times x plus 3. And at first this may be like, oh, what do I do? 5x times x plus 3. We just multiply those together. 5x times x is 5x squared. And then we distribute that into x plus 3. So that's going to give us 5x cubed plus 15x squared. Now, on top, we do have something in common that we can take out. They all have 5x. And if I take out 5x, that gives me 1, because that is exactly what I had here, plus x squared plus 3x over our common denominator, 2x times x plus 3. And now, because on the outside I have an x and an x, it doesn't matter that it's 5x and 2x, it just matters that it's x and x. I can cancel those x's out. And so my final answer, I'm going to rearrange this into standard form to make it look nicer. But this right here is my final answer. X can't be negative 3, but even though I canceled out the other x, which would be a 0, it still restricts our problem because at the very beginning, we couldn't plug in 0. Now, this common denominator is going to have a 5 and a 2, which makes it be 10, and then we also, of course, have to have x squared and y. So this first fraction has 5, to get 10, we have to multiply by 2x squared y. And then here, we need to multiply by 5. And so 2 times 3 gives us 6. We have x squared, y times y is y squared, plus 5. And there's nothing in common on the top that I can take out of both, so I can't cancel anything out. This is my answer. X can't be 0 and y can't be 0 because x and y were both on the bottom at the beginning, and it's x squared and y just being multiplied together. They're not being added with anything, so that's why they're both 0. Now, we finally got a subtraction problem here, and subtraction, one way that might help you to think of it is you're adding a negative. Technically, we could put the negative on bottom instead of the top, but that's not a good idea. Put the negative on top with our numerator, and so pretend like we're just adding a negative 5. Now, we need a common denominator. So we need 5b minus 2, and we need b plus 5. Which means our first fraction is going to get multiplied by b plus 5. And our second one is going to be multiplied by 5b minus 2. And so the first one will have to distribute 3b, and we get 3b squared plus 15b. Now, because I switched it to plus a negative, now I know that I need to distribute a negative 5. And if we hadn't thought of it like that, we might mess that up. So this is minus 25b plus 10. So we've got some like terms in the middle. And on bottom we have 5b minus 2 and b plus 5. And so we could check and see if the slide and divide thing would work on this. 3 times 10 is 30. There's nothing that multiplies to get 30 that will add to get negative 10. So we're good on that. Now, b can't be negative 5. And then if you think about the 5b minus 2, if I set that equal to 0, what do I have to do to solve? You might be able to do this in your head. If not, you need to write it out. I would add 2, get 5b equals 2, divide by 5, and get b equals 2/5. So that's the other thing b can't be. Now this is what we call a complex fraction because we've got fractions on top of fractions. How complex? So what we want to do to start off is get a single fraction on top. Because if I have a single fraction on top over a single fraction on bottom, I can just treat this like a division problem. So on top, I need a common denominator, which would be x times 2 or 2x. And so the first fraction, I need to multiply by 2, and the second one I need to multiply by x. So on top I have 8 plus x, and then I still have a common denominator of 2x. So at this point what I do, because I'm dividing, is I leave the top alone, 8 plus x over 2x, times I flip the bottom, so that becomes 4 over x squared. And so I can check to see if anything simplifies, like the 4 and the 2 here, since it's 2x not 2 plus x, I can cancel out a 2 from each of those, and that's actually all I can do. So on top I can write 2 times 8 plus x, and on bottom I can write x times x squared, which is x cubed. And in these instructions it didn't ask us to say the restrictions. It would probably be that x can't be 0, but we don't have to state them, so yeah. 16 is a similar problem, except now the two fractions are on the bottom. So those are the ones we want to get together. We could make our common denominator be x cubed, but hopefully you can see that, oh, I just need to multiply this by x and I'll get x squared for my common denominator. So I have to do that on top and bottom. So I get 5x plus 25. And then I'm going to leave the 5/9 alone and flip the bottom, x squared over, well, hey, these have a 5 in common. Let's take it out. So 5 times x plus 5 is on bottom. So since they both have a 5, well, since there's a 5 there and a 5 there, those can cancel. And that leaves me with x squared over 9 times x plus 5. The rest of the stuff is from our Chapter 8 test. So the formula A equals P e to the RT. P is for what we put in as a deposit, so that's the $5,000. R is our interest rate, and we have to change it to a decimal. And T is our amount of time in years, and so we just need to fill this in. And then type it in. And this is actually really easy to type in. Because it's all on one side. Remember the E button, you can do second divided by or second ln to get to. And so A equals, this is money, 6749.29. Now let's solve some logarithmic equations. Remember that if there's not a little number here, it would be a 10. And then because I want to get the logarithm to go away and there's only a logarithm on one side, I would rewrite this as an exponential equation. My base is 10. I go around, the exponent is -1, and it equals n minus 5. Well, 10 to the -1 I can put in my calculator and get 0.1. And then add 5. So I get 5.1 equals n. On this one, since there is a logarithm on each side, I just cancel the logarithms out, basically. In order for log base 9 of something to equal log base 9 of something else, the somethings have to equal each other. And then this just becomes a problem of solving a quadratic equation. I need to get everything on one side. I'm going to move to the right so that I can have a positive n squared, because positive n squareds are better, easier to work with. So 0 equals n squared plus 7n minus 18. And so to solve this, I either use the quadratic formula or I can factor. So what multiplies to get -18 that adds to get 7? I'd use +9 and -2, which means n equals -9 and +2. I'm going to rewrite this as a logarithm to solve for r. That's the only way to get the r out of the exponent. So log, I start with my base, which is 18. I come around here and pick up 50, and it equals my exponent, which is r. I just need to type this into my calculator, which, remember, we go to math and scroll up and find log base, type 18, and then 50, and I get a nice decimal, 1.353. We have to look at this and say I have too many logarithms, and so because I'm adding between them, I can combine them into a single logarithm. A plus changes to multiplication, a minus would change it to division, which happens on the next problem. So now that I have a single logarithm, I can rewrite this in exponential form. 8 to the first equals 10x. I can divide both sides by 10. And x is 8 to the first is just 8. So this is 4/5, or if you typed it into the calculator, you'd get 0.8. 22, this minus sign, is going to change our logarithm. We're going to combine it into one logarithm where we're dividing. So log base 6 of x over 3 equals log base 6 of 37. And so now that there's just a single logarithm on each side, I can cancel them out. So at the beginning, I couldn't cancel all of them out because it doesn't work like that. I have to have a single logarithm on each side to cancel out. So I had to combine these, and because it's minus, it changed to division. To finish solving this, I just need to multiply by 3 on both sides so that x equals 111. Solve for v, so I need to add 10 to both sides. And then I'm going to rewrite this as a logarithm. So this is log base e of 13 equals 4v. Now, you might remember that log base e is the same as having the natural log. And so we can do ln of 13 and press enter. And then to finish solving, we need to divide by 4. So we get v equals 0.641. These last two are where we're just rearranging, so I would rewrite this without the log by writing the base, going around, and 20 is our exponent, and it equals 177. Oh, that's a negative 20. I didn't mean to leave the negative off. K to the negative 20 equals 177. Now, this one, I want to put the logarithm back in, so it's a base of 2 of n equals my exponent, which is m. So that's my answer.